Started recording. Please, if you are not going to speak, please mute your mic. Hello. I'm asking Dao Yang.
Yeah, Tony can leave.
I'm here.
Nobody.
I'm trying to mute, but it's. Oh yeah, now it's mute. Yeah, it looks like many people working from home. Please mute your mics if you intend to speak. Okay, I'm doing some housekeeping. Yeah. Okay, welcome everybody. This is Trusted Firmware M, Open Technical Forum. So today we have only one topic in the agenda. This is proposed by Mate regarding the tool he developed and prototyped. Yeah. And yeah, after his presentation, yeah, I will share some few minor topics. So, Mate, would you like to present this?
Yes, sure. I try to share my screen. You should see a front page of a PowerPoint presentation. Is it present or is it there?
I can see it.
Cool. Okay.
Yeah, I can see.
So yeah, that sounds good. Okay, so then I start. So first of all, thank you for your thanks for coming to this. I'm sorry, could you please mute your mic if you have no question, please? Thank you. Okay, so so thank you for coming for this presentation, where I'm going to talk about the tool that we've been working on recently. The goal is to be able to test more advanced interrupt scenarios in TFM than we can test at the moment. And let's jump in. So first of all, let's have a look. What are the limitations of the ways that we are currently using for testing interrupt handling in TFM? So the way it goes today is that we use actual timer peripherals to trigger the interrupts, and we want the interrupts to be triggered at a specific location during code execution. So during the test cases, basically we do busy waits at the points where we want the interrupts to be triggered, because it is very difficult to set up the timers in a way that they hit exactly at the moment when we want them to be hit. It's probably a bit more straightforward to have a look at the sequence of an actual test case. In this test case, we want to trigger an interrupt that is handled by this secure service 1, and we want the interrupt to be triggered when we are executing in this secure service 2. For this, because service 1 is handling the interrupt, it is basically it is owning the timer peripheral. So service 1 is going to set up the timer to be triggered at a later point. Then we call in secure service 2 and entering a while loop, waiting for a flag, continuously checking on a flag that we expect to be set by the interrupt handler. And there is some looping for some time until the timer peripherals decides that it is time, that so the set time has elapsed, and the MVIC notifies the core, and the interrupt handler in handler mode starts executing. The interrupt handler does some lookup in the secure, so the partition database, selects the secure service 1 that is assigned to that IRQ, and starts the interrupt handler of that service in thread mode. The service 1 sets the flag that is on which the secure service 2 is waiting, and after that returns to handler mode. The IRQ handling is acknowledged in NVIC, and the CPU resumes the execution of secure service 2, which then notices that the flag has been set, and it can return to service 1. And the checking of the flags that it has been really set, and the return value of the service 2 is checked in service 1, and this basically concludes the test case. Now, what are the limitations of this approach? Why do we want to have something more than this? The problem is that in the current platforms that TFM is ported to only have 2 timers, and 1 timer is allocated to non-secure, the other one is to secure. This means that we cannot test scenarios, for example, when a secure IRQ interrupts a secure interrupt handler. Although it's very not difficult, but it takes some time and it's not very nice. So it doesn't look very nice in the code, the implementation of the test case, because at every location that we want to interrupt, we need to insert a while loop. We cannot really create negative test cases with this setup. So, for example, if we want to check that the interrupts are actually, so for example, we want to check what happens in a code that runs during interrupts are disabled. So we want to trigger an interrupt, and we want to observe that interrupt, so the interrupt handler for that interrupt doesn't start executing. That's, well, probably this could be solved, but it would look very ugly if we implement it. And one last thing is that the flag that I mentioned earlier, that is set by one service and checked by another service, currently these are global variables, and that's also not a good practice, because on higher level isolation this probably won't work, because secure services can't really access each other's resources. And we actually, so these are not just theoretical limitations, because we actually hit these limitations. We had this mail on the public mailing list of TFM, where one of our partner noticed an actual bug in the an interrupt handling code of the library model, and I couldn't copy here all the mail because that would look so tiny and there's so much information there. But the main point is that so he found this bug with doing a code review, and wasn't able to check whether whether the thing that he found really causes an error or not. He was just only speculating that. And yeah, so this is an actual limitation of the current approach. So what else could we do? There's a possibility to directly write NVIC registers from code. There is this software triggered interrupt register, STIR, and the other one is interrupt set pending register. So we could use these to generate interrupt from certain points of code by simply writing to these registers, and the desired interrupt then goes to pending. However, this solution has limitations as well, because these registers only available from privileged mode, and it is not possible to trigger secure interrupts from non-secure code by writing values corresponding to a secure IRQ from non-secure. In theory, there is another possibility that we can use the debugger to write these registers. Well, obviously, what is one thinks about this, it turns out, so doing this manually is very slow, very labor intensive, and a very big problem is that it cannot be automated by CI. And the idea that we had for this tool that started developing it is that we had a thought whether this is really necessary true. So is it really labor intensive to use a debugger to trigger these interrupts? And what we found is that it is not really true, because so this is how a typical debugging setup looks like. One is interacting with the debugger GUI or CLI. The debugger is running on the host. It is connected to the target under debugging during some way, and the debug subsystem on that system can access to the internal interconnect in the CPU and can directly write the NVIC registers. Now it turns out that most of the debuggers, at least the ones we are using, have some kind of script interpreter. So it is possible to create a script to automate the testing procedure. It's quite convenient that the two debuggers that we were looking at both have a Python interpreter. So much of the code that is created for the tool can be reused for the two debuggers. So let's see how the actual code, how the script execution would look like in practice. Sorry if the graph is too small to see. I try to go it through step by step. So the CPU, so we simply start the CPU that boots up, and at some point we attach to the core with the debugger. We start the script. The script reads in some config files that describes the test to be executed. I'll talk about that a bit later, and starts execute the first step in the test case that is defined. It sets a breakpoint and continues the target. The target continues, executes instructions as it would do normally, and when the breakpoint is hit, the debugger script starts to execute the next step. It sets a breakpoint, sets an interrupt pending if the test case requires that, and again continues the target. The target continues, executes instructions as normally, and at some point the breakpoint is hit. And at that point the script kicks in again, and it can do sanity checks on what breakpoint was hit, whether that was whether that was the expected outcome of the previous settings, so setting the interrupt pending or not. And basically this iteration continues until the script runs out of test steps, and that is going to mean the end of the test execution. And this is how the architecture of the software stack that we had for testing this way. On the top, there is some common logic in the script that reads in the config files, executes the test cases and does the checkings. And there's a not too big debugger abstraction layer for each debugger, because of course the Python interface for driving the debugger is different for the two debuggers. And going down in the stack, for example, for GDB, there's the Python interpreter that executes the scripts that drives the GDB engine, and the GDB engine is connecting to through TCP/IP to an OpenOCD server, a GDB server that is hosted by an OpenOCD instance, and that OpenOCD has a CMSysDub driver that can directly connect to the target. It's so the setup is a bit simpler for the ARM Development Studio debugger, because the Python interpreter and the CMSysDub driver is integrated in a single software, so there is a few less steps. And now the config files that I mentioned earlier. So the idea is that we try to, well, so we currently have we have 3 input files for each test. First, there is a list of breakpoints. The breakpoints are the code locations where we might want to trigger interrupts or do sanity checkings on whether. So yes, so basically where we want the script to examine the execution. So where it went, and you see there are possible ways to define location in the code. You can have specify it with a symbol or location in the code, and there is also a file for defining the IRQs. This is basically assigning a symbolic name for each IRQ line number. And the third file is the actual description of the test case, where you can now use the symbolic names that were defined in the previous files. I go through quickly on this file, but it's quite straightforward, although not very nice. So these files, you can notice that these are JSON files. It's not the easiest to read, but the easiest to parse from a script. So we selected this, but this can of course be changed later if we want to make it more convenient to read these files and write them. So this test case has 3 steps. The first step is simply to wait for a certain symbol or certain point in execution. This specific breakpoint, I think, is in a secure service. And so when the script is started, the breakpoint is set for this location and the target is continued. And when the target next stops, we go to the next step. We set we set a breakpoint for this location. This is inside an IRQ handler, and then we trigger the IRQ handler. We trigger the IRQ in one of the NVIC registers and let the target continue. Now the trick is that with this expect keyword, the tool sets actually 2 breakpoints. It sets this breakpoint and this breakpoint in the third step. And this happens because we want to. So after setting this interrupt pending, we want this handler to be executed, and we want to check whether this handler has been skipped or not. So we need to set this breakpoint at this location and this location as well. And when the target stops, we can check whether this breakpoint was hit or this breakpoint was hit, and we can define. We can decide whether the test execution went as we expected or not. And after this, I would like to show you some demo. This is not going. So yes, basically I would like to show you how this looks like in the practice. Unfortunately, I don't have an actual board with me, so I will use FVP, and unfortunately FVP cannot be connected with GDB, so I can only show you the RMDS version of the script. So we connect to the FVP. Let's hope it starts. Yes, it started. And it stopped in the reset handler. And commands. And I have the command for the script here. I'm sorry, the letters are too small. So basically we source the actual script, the IRQ test.py. It has several command line parameters, one file that specifies the IRQs. This is the IRQs.json that I showed you earlier. Then you have to specify the breakpoints file for it. This is just like as I showed earlier. And this is the test case file, the third one, test01.json. And when I submit this command, you see that execution is started. I have a telnet terminal here, and you see that that was quite quick. So the step 0 started execution immediately. We set a breakpoint for, sorry, let's try to make this bit bigger. So we set a breakpoint at this location and continued execution. This is so the lines that are starting with these equal signs are emitted by the script, and the ones that has no prefix are emitted by the debugger itself. So the execution stopped as it was expected. We are querying the triggered breakpoints, but that's not that important at this step of the test case. We remove the previously set breakpoints and have a look at the next step. Sorry. So this is how the, I should have showed you this one first. So this is the actual test case that we were executing in this particular instance. So we have one breakpoint set. This is just to make sure that we are, so this is not the mainstream, not mainstream, sorry, upstream TFM code, but it has some little tweaks that it has a while loop that is executing secure services, or in a while loop calling secure services to be able to execute more than one test. So first we wait for the beginning of this loop. Then we wait until the execution ends up in a secure service, and then when we are going to trigger the interrupt. So yeah, you can see that the steps are indexed from 0. So what we are really interested in is the 0, 1, 2, the step 2. So you can see that one breakpoint is added for this expect keyword, and one breakpoint is added for the next step. We are triggering the interrupt. The method of writing triggering the interrupt is writing to the stir register, and we continue the execution. And yes, well, basically this is what continues. What might be interesting, I can show you that what happens when not the expected thing happens. So for example, there is another interrupt that is called service on high, and if we run this test again, we should see a failure. Yes. So the execution stopped at EIQ test iteration start. So in this one, instead of this handler. And yeah, basically that was it. I wanted to show you. And so what improvements left in this tool? Of course, there are plenty. I get this question many times, that whether this tool can be used for randomized execution of interrupts. Yes, of course. It just needs to be implemented. We can definitely improve the config file formats because the keywords are invented by myself, so not very good. And the file format, the JSON, is not very user-friendly to read. We can add further functionality for the tool. So for it cannot only be used for testing IRQs, but I don't know, injecting faults, or I think there are plenty of ways using it. We can improve usability. You saw that I did know, so I only specified the 3 input files, and that was easy because in the ARM Development Studio, the debug configure, so I can save the symbol files for the debug configuration, and those are loaded automatically automatically by the debugger, but this doesn't happen with GDB. So you have to do this manually before running the script, but there is nothing stopping one from doing this actually from the script and attaching or connecting to the GDB server from the script as well. So this also just question of implementation. And of course, one goal we want to have this tool is to integrate with CI. These are so the script interpreters are definitely a full script interp. So yeah, the whole toolset of Python is available in them, so we can write config files from them, or I think the return value of the script can also be queried somehow if a CI system starts the debugger. So there's nothing stopping anyone from integrating this to CI. And I think that's all I wanted to share with you today. Thank you for your attention. And now, if you have any question, then it is the time to ask it.
Yeah, thank you, Mate. Yeah, thank you for showing us a clever way to use our tools. If anyone has a question. Please speak up. Yeah,
Or you can use the chat as well, I think.
Yeah, please use chat as well. Yeah, if you feel more comfortable to write instead of speaking up. Yeah, I think we have this scripting for quite a while in our tools, but I don't think it was widely used. So this is what it shows us how it could be utilized. I have a question, Mate. You said like the scripting is available for GDB and for DS.
Yes.
Tools, is it compatible? Tools, can we use one script to use in another tool?
Yes. So I try to.
Syntax is different.
So these are both Pythons. So the interpreters are both Python interpreters. So the actual syntax of the script is basically the same. What I did is basically I created a simple debugger abstraction class. So this is basically a class that you have to implement if you want to add your debugger to it. And the main script logic, reading the file and executing the test case, is common, and it is calling these APIs. So if your debugger has a Python interpreter and you are able to implement these, I don't know, 5 functions, then so if you implement these 5 functions, you are ready to use the tool as it is at the moment.
Okay, so you develop some abstraction layer so anybody can implement or insert their own debugger or tool.
Yes, exactly.
Yeah, great.
I might have missed it, but what were the 2 debuggers that you used? The sort of physical debuggers?
Yes. So what I used for the demonstration here, that was using an FVP, but
FTP is a platform, I think, but the question was about debugger. It was a DS5.
It was the it was DS. It was ARM Development Studio that you seen using, and unfortunately I couldn't show the GDB version because we cannot attach to an FVP via GDB, and I don't have an actual board here with me.
Okay, so I meant a physical debugger like a JLink, which I don't think you can.
Oh, I use CMSysDAP during testing. So I used Musca S1, I think, the board I used, and I connected it to my PC with a simple USB and was using CMSysDAP.
Okay. You had mentioned there was 2 options. I guess the other one was. I thought you mentioned there was only two debugger options that were supported that you could.
Oh no! I meant the 2 debugger tools. So I meant the debugger software.
Okay, sorry. Thanks for that.
No problem.
I have a question.
Yeah.
You showed the mail in the presentation, and
Yes.
Can you refer back how that issue was resolved with the use of this tool?
Well, solving the issue was so the issue itself wasn't too difficult because there is some kind of stacking mechanism implemented in a library model for the interrupt handling, and what our partner noticed is that the popping and pushing mechanism wasn't properly implemented. So to actually trigger that error, you need to have interrupts, a secure interrupt interrupting another secure interrupt handler. So fixing it was trivial. the problem was that we didn't detect it during testing because we didn't have the tools to implement such a test case.
Okay, and how could you use the tool to reproduce that scenario?
That's actually I am not sure that I'm going to be able to find that, but I actually have a test case for that. Let me look it up quickly. IRQ test tool. I'm sorry. I think this is it. So this is how it looks like. So simply, it's very similar to the previous test case. You trigger an interrupt. You expect it to stop in this handler, and when it is stopped in the handler of the this IRQ, then you trigger another one. And I won't be able to show this failing because my current baseline TFM that is compiled in the debugger has a fix for this. But if you go back to that revision back in, I don't know, end of December or something similar, then you will be able to see the TFM actually crashing.
Yeah, but then you were able to set two breakpoint into handler and trigger in a tail chaining mode of the different low and medium interrupt handler. Is it right?
Yes, not exactly tail chaining, but yes. So two interrupts were active at the same time.
Okay, so even inside the interrupt handler, trigger a higher priority interrupt.
It is possible, yes. We also have test cases for so I also have a test case for triggering a lower priority interrupt in a higher priority interrupt handler, and the test case can check for whether that interrupt is so the higher priority interrupt is not interrupted, but this time a tail chain happens when the higher priority interrupt returns. It won't return to thread mode, but the lower priority interrupt will continue execution. So we can test that as well.
Okay, thank you.
Yeah, but I have another question. Unless anybody else wants to ask Mate. So just a reminder, we have in TFM, we have two modes, IPC and library modes. Mate, do we, using this technique, can we run it in IPC mode?
Yes, of course. So it is completely agnostic from the software. Actually, if someone has a software that somehow is so if you don't want to, if you want to test interrupts in your system and you are not actually interested what is happening on the peripheral, but it is enough for you that NVIC is triggering some random interrupts and you want to see how your system reacts to that, whether you have race conditions or not. This tool is basically universal. There's no reference in it to TFM. The JSON files, the data files only contain numbers for the interrupt lines and some code locations. So this is not even TFM agnostic. So yes, it can be used with IPC model, library model, or any other software or OS, or if you want to use that. So yes, there's no limitation in that.
Yeah, thanks. Sounds very good. And can you imagine how it will work in a multiple CPU, like dual CPU system?
That's a very good question. I actually give a bit thinking to it, and as far as I know currently, if you want to debug a multi-core system, then you need a separate debugger instance for each core. So you basically attach with a separate debugger instance to each core. So you can't really. So if you want to interact both core, then you need to need to run 2 instances of the scripts, and if you want to synchronize the working of those 2 scripts, then those needs to be communicated somehow. So this is something that is not trivial to solve, but I can imagine that there's a solution for that, but that's definitely non-trivial.
In my opinion, it's rather benefit of this technique in multi-CPU if you have to use multiple debuggers, because in that case, manual work and manual synchronization would be nightmare. And using the scripts, it's probably the only way how to do it.
Probably yes, but then implementing the scripts then itself is a nightmare. So because you have the same synchronization problem. So yes, this probably can be done, but it is a non-trivial work.
Right. Okay, any other questions, please? If not, so thank you, Mate. And do you have any plan to make it available someday in TFM?
I think the code is currently in the shape that it can be released with the tagging prototype. So this is of course not a commercial quality tool, but as far as I know, the TFM team is quite busy at the moment. But after there's some so so after the end of the quarter, I think that's completely possible. So this can happen, I don't know, in early April or something similar.
Yeah. Thank you again.
Thank you very much for your attention.
Is anybody wants to raise any ad hoc topic not listed previously? Just feel free to speak up or use the chat. I have a small, not presentation, it's just a slide to remind you what was discussed on the mailing list, and if we have something extra not listed, not discussed in the mailing list, so this we can use it, this forum. I'm trying to share my screen. Please let me know if you can see.
Yes.
Okay, so those are topics I found kind of worth to discuss. What was touched in the mailing list. Sorry if I missed something, so please add here. And there were many other topics, but I have a feeling like it was discussed and closed. Only those one might be interested for discussion. The first one is key generation. It takes quite a long time, minutes, mainly it's because of lack of, we believe it's because of a lack of hardware for entropy generation. So if you apply or add hardware on your platform to generate entropy, it should be faster. But we have a sign that it's not the case, and sometimes it's also slow. So maybe it's a wrong build of the TFM, which is still using the software. Okay. Another one is we now is in code freeze. So please review and test the TFM before it goes to the version 1. We plan to do it as soon as possible. And after code freeze, we should fix those bugs if we can find and adjust the documentation. Another one, there was a topic raised by Reinhard in a place of in a space for improvement on the speed and size of on transition between secure and non-secure call. I think it's still open question, and we will get back to this in the second quarter. And a few reminders. Last technical forum, there was Minos presented the strange behavior of different compilers, how to handle the SFN section, but it's not about SFN section, it's for any section located in a stack of the function. So it's kind of implementation defined and unpredictable. And there was a presentation for Profile 1 by David Hu last time. So please review the document. It is available on technical forum. And two sessions before, there was a fuzzer tool presented by Gary. Yeah, thanks, Gary. And now the tool is available on TFM. Yeah. Everybody welcome to use it. Any comments from the forum? If no, I think we have nothing to discuss today. It's the first time we are going ahead of time. Thank you, everybody.
There is a question on the chat.
Oh yeah, thank you. Thank you, Tamar. Another topic is, yeah, I'll read the chat. Another topic is, are there any WIP?
Work in progress, I think.
Could you help me with WIP? What is
Work in progress. Yeah.
work in progress to go to CMCs, to upgrade the CMCs. Thanks, Tamar. At this moment, no. We are not progressing. Yeah, we are considering this, but yeah, it's my answer is no. But thanks for bringing it up. Yeah, I think we should do it.
Hi, Thomas. I think your topic is related to the IR toolchain support in TFM. Is it?
Yeah. Looks like this is the case. Thomas mentioned that IR libraries are broken in CMSIS 5.
Yeah, I also reproduced the same issue from my side with IR toolchain to build TFM. Besides the CMSIS need to update to 5.7, and also embedded crypto have some changes need to be merged. Maybe after all these changes are in an official tag, then TFM can update the dependencies tag to support IR toolchain.
Yeah,
that's my opinion.
Yeah, good topic. I think we should do it to support ER, and I would ask Thomas to add a ticket to Fabricator and raise this on a mailing list.
So get it right that these are blocking issues to bring up the IR toolchain.
I think that's a blocker issue because without this library, we cannot build TFM with IR toolchain.
Okay, we'll see how much it will cost us if it's easy. I think we can just version up to CMCs if it's back compatible. So if it's not a big deal, so we can do it as soon as possible.
Okay.
Yeah. Thank you, Thomas, for rising it up. Any other questions? Okay, if not, so yeah, thanks everybody. Let's close this session and see you in 2 weeks. Have a good day. Goodbye.
Thanks.
Thank you.
Bye-bye.
Bye.
Bye.
Thank you. Bye.